Good day everyone, and welcome to where we are putting together solutions to those math and science topics that we are getting problems with. In this video, we'll be concentrating on CSEC Mathematics and the past papers on the topic of statistics. This is our second video in this series. In our last, we did the past papers. We went through it from May 2009 to 2013. And this one we will be going through the next 5 years, from May 2014 to 2018. So feel free to like the video and add comments down below so we can help you in whichever area of maths or science that you need help in at both the CSEC or CAPE level. Let's look at the 10 major topics in CSEC Mathematics. And our focus in this video is on the fifth topic, statistics. This is tested in the multiple choice paper 1, for 6 questions out of the possible 60, and in paper 2 for 9 marks out of the 100 marks. Let's recall what statistics is. It is a branch of mathematics dealing with large collections of data or information. And it can be presented in terms of different formats. So if we consider that, then we can subdivide this into data being either in an ungrouped or grouped. And that the statistical diagrams that may be presented with it includes pie charts, bar graphs, line graphs, usually in the ungrouped section, and histograms, frequency polygons, and cumulative frequency curves or ogives in the grouped section. Not just that, but we also must take into account that there are central tendencies that we can get from both factors, whether it's grouped or ungrouped, such as the mean, the mode, or the median, and also measures of dispersion, which include calculating the range of the data, the interquartile range, the semi-interquartile range, and even the standard deviation. As we look at the past paper questions in this second in our series on statistics, we will notice that the year 2014 was based on a frequency polygon, 2015 on a line graph, 2016 a histogram, 2017 cumulative frequency curve or ogive, and 2018 on a pie chart and a frequency polygon. So there was a spread over the 5 years looking at 5 different statistical diagrams. In May 2014, number 7, a class of 30 students, 30 is important, 30 students counted the number of books in their bags on a certain day. The number of books in each bag is shown below. And we can see we have 3 rows of 10 columns. As such, these represent the 30 students. So part A says, copy and complete the frequency table for the data shown above. And in our table we have 4 columns, the first of which is the number of books represented by X that the kids had in their bags. We can see there was a range with the least amount of books in a child's bag was 1, and the most was 7. We can identify that by the yellow triangles above that there were 2 kids with 1 book in their bag. So if we added that, we would be able to get 1 and 1, which is 2, or multiply quickly, 2 ones are 2. Similarly, using the purple triangles, we can see there were 3 kids with 2 books in their bags. So in total, 3 2s are 6. Those 3 kids had 6 books in their bags. And if we complete in the table, we go on with the others. With 3 is represented by the blue circles. We see there were 5 of them, right? So there are 5 3 to 15 books. And how many kids had 4 books in their bags? We can see red circles. There are 6 of them. So 6 4s are 24 books in their bags. For 5, represented by green circles, we can see there were 7 kids with 5 books in their bags. So that means that their total was 35 books. For 6, it would be the purple circles, and there are 4 of them, so 6 4s are 24. And the remainder would be those kids with 7 books in their bags. 7 3s are 21. As such, from this, we can double check if we add up the amount of pupils or the frequency. If we add 2 plus 3 plus 5 continued, then we can see the total is 30. And that can be represented as sigma f, sigma meaning sum of the f's or sum of the frequencies. So sigma f is equal to 30. And if we total fx, which would be the number of books in all, by adding 2 plus 6 plus 15 onwards, it will give us 127. So let's look at part B. State the modal number of books in the bags of the sample of students. What's that asking us is which x value, which number of books came most frequently. Remember MO for mode, MO for most frequent. So that would be 5. So we found that if we sample the bags, that the bag with 5 books came most frequently. Part C, using the table in A or otherwise, calculate the total number of books. And we've done that already, sigma f, which is equal to 127. And the mean number of books per bag. The mean number of books represented by x bar is equal to sigma fx divided by sigma f, which is equal to 127 divided by 30, which is equal to 4.2. And the last part of the question, determine the probability that the number of students chosen at random has less than 4 books in his or her bag. Less than 4 books means either 1, 2, or 3 books in their bags. So that total is 2 plus 3 plus 5, which is 10 over 30. And of course, remember it's a probability, so we put it out of the total. And 10 over 30 can be broken down and it will give us 1/3. In May 2015, number 7, the line graph below shows the monthly sales in thousands of dollars at a car dealership for the period July to November 2014. So we can see on the x-axis the months July, August, September, October, November. And on the y-axis from 0 to 40 in thousands of dollars. So part A says, complete the table to show the sales for each month. And we are given the values for July, 13,000, and September, 36,000. So we're missing August. And if we look at August, August lines up exactly with 20. So the sales for August will be 20, of course thousands. October will be exactly between 20 and 30 on that main line there, 25. And November exactly between 10 and 20, which is 15. So we've completed part A, but as we're doing that, we can total. So we can add 13 plus 20, going on up to 15. And we can see that the total sales, sigma sales, is equal to $109,000. Part B, part 1, between which 2 consecutive months was there the greatest increase in sales? And we can see that the only time there were increase in sales were between July to August and August to September. So which one was the greatest? The one that was the steepest, which is August and September. Between which 2 consecutive months for part 2 was there the smallest increase in sales? And the only other time there was an increase in sales was from July and August. So that would be the answer. For part 3, what feature of the line graph enables you to infer that the increase in sales between the 2 consecutive months was the greatest or the smallest? Well, what told us that would be the gradient of the graph, or how steep the graph was. The steepness or the slope or the gradient, all meaning the same thing, was the characteristic that we needed to be able to tell which was the greatest increase. For part C, calculate the mean monthly sales for the period July to November 2014. In calculating mean, which is symbol X bar, we get the total, which we've already done, which is 109,000, and we divide it by the number of months from July to November, which is 5 months. So 5 into 109,000 is exactly $21,800 is the average or mean monthly sales. For part D, the total sales for the period July to December, so we're including another month now, not stopping in November, but including December, was $130,000. Calculate the sales in dollars for the month of December. So if the sales from July to November was 109,000 and it increased to 130,000, as such, the difference would be how much sales there were in December, which was 130 take away 109, which is equal to $21,000. And complete the graph to show the sales. So we need to represent that information on the graph. So we put in our point and we connect it with a straight line. May 2016, number 7 states that the 20, and that's important, 20 bags of sugar were weighed. The weights to the nearest kilogram are as follows, and they gave us the 20 values in terms of 4 rows and 5 columns of information. 4 5s are 20. And they gave us a table in which they gave us all 5 class intervals, meaning that they have grouped the data. So from 1 to 10 would be the first interval, meaning how many bags were there with the weight between 1 to 10 kilograms. And the next will be 11 to 20, and so on, 21 to 30. So it means that it keeps increasing by a value of 10 when we're going vertically downwards. So for part A, copy the frequency table for the data shown above. So you can pause the video here and work it out. Right. I've worked it out, and as such, we can see that in the first instant, the first interval, there are 1, 2, 3. So the tally will have 3 strokes and the frequency will be 3. For the second interval, we'll have 4 strokes and the frequency is 4. So there were 4 bags of sugar between 11 and 20 kilograms. The next one is 5. The fourth one is 6. And the last one, 41 to 50, will be 2 bags. And if we total the frequency, 3 plus 4 plus 5 plus 6 plus 2 will be equal to 20. And that collaborates with 2 sets of information above. One, the first thing that was written, 20 bags of sugar. And if we look at the numbers 4 by 5, there were 20 numbers that were given. Now that we've completed part A, we can move on to part B. For the class interval 21 to 30, so if we look at that, that'll be our third interval, right? The middle row in our table. State in part 1, what is the upper class boundary? So we can see from 21 to 30, the upper limit is 30. But if we consider the class boundary, it means that we're closing up the space between the 30 in the third interval and the 31 in the fourth interval. So to close that space, we need to find the middle of 30 and 31, which would be 30.5. So that is our upper class boundary. Our class width would be a couple different ways to do it. One way is to see how much it increases vertically downwards. So it moved from 10 to 20, 20 to 30. So it's adding 10 all the time, so the class width is 10. It's done more conventionally where we take the upper class boundary, 30.5, minus it from the lower class boundary, 20.5. It'll still give us the same 10. And the third point, what is the class midpoint? The class midpoint will be taking the 2 values, the upper and lower, and dividing by 2, which means it's finding the average. So if we take the upper limit and lower limit, 21 plus 30, that's 51. 51 over 2, 2 into 51, 21, 25.5. Now that we have done A and B, let's move on to the last part of the question, part C. Using a scale of approximately 2 centimeters equal to 10 kilograms on the x-axis and 1 centimeter to be equal to 1 bag on the y-axis, draw a histogram to illustrate the data. So as we see our graph of frequency versus weight in kilograms, our x-axis is labeled weight in kilograms, and my scale has 2 centimeter borders, right? So that means that if I'm going along the x-axis following the scale, every 2 centimeters is 10 kilograms. So I've plotted 0, 10, 20, straight up to 70. And on the y-axis, 1 centimeter is equal to 1 bag, but I have 2 centimeter blocks. You can check to see which one your paper has. If it's 1 centimeter blocks, then your marking should be a little different from mine, but they will still line up. So my 2 centimeter blocks mean on my y-axis, for 2 centimeters, I'll have 2 bags, so it'll be 0, 2, 4, 6, 8, 10. Good. Now, before drawing the histogram, I'd like to draw a bar chart using those values from the tables from 1 to 10. In the first one, I have it in light blue. It will go up to a frequency of 3. 11 to 20 in red will go up to 4. 21 to 30 will be in purple, it goes up to 5. The next one, 31 to 40, in pink, goes up to 6. And the last one, 41 to 50, is green, it goes up to 2. Spaces in between all the columns, which means it's a bar chart. Now let's convert it into a histogram. So all the spaces becomes 0.5 wider to the right and the left. So the spaces are now closed. And as such, this is our histogram. May 2017, number 7, the question asks, the table below shows the speeds to the nearest kilometer per hour of 90 vehicles that pass a checkpoint. So if you look at the table, we can see it's given as group data. And recognizing that, we can see that there are 1, 2, 3, 4, 5, 6 groups, right? And to move from one group to another, we're adding 20, right? So we also notice that the frequency, 5, 11, 26, and continuing for each class interval, if we total that sigma f will be equal to 90, which corresponds with the 90 vehicles that was given in the sentence above. So the first part of the question is asking us, for the class interval 20 to 39, which is our second class interval, what is the upper limit? And the upper limit will be the larger value given there, which is 39. And is also asking what is the class width. And there are multiple ways to find the class width, one of which is to find the upper boundary, which is 39.5, minus the lower boundary, 19.5, which will give us 20. Or we can simply say, how do we move from one class interval to another? By adding what value? If we look at the lower limits, 0 add 20 is equal to 20, add another 20, 40, 60, 80, and so on. Or if we look at the upper limits, 19, and we add 20, 39, and another 20, 59. So we keep jumping by 20. As such, the class width is 20. And in part 3 of the question, they're asking us, 16 vehicles pass a checkpoint at no more than what speed? And if we look at 16 vehicles, the first 16 vehicles, then we can see that as the first 2 intervals, right? So they do not pass at a speed greater than the upper boundary, which is not 39, but halfway between 39 and 40, which is 39.5. Remember, we're looking at this as if it was a histogram. In that sense, not as a bar graph where there's a space between 39 and 40. Right? So recognizing that now, we can go on to part B, copy and complete the table. So the table is complete in the first and second columns and partially in the third column. And the third column is cumulative frequency. So if we recall, cumulative frequency means the total frequency up to that point. As such, for the first interval, there were only 5 cars. Right, so 5 vehicles, so the cumulative frequency was 5. In the second interval, we added another 11, so we get 5 and 11 is 16, and we go on 16 and 26 by adding the third interval will give us 42, and then 42 and 37 for the fourth interval, if we include that, will give us 79, 79 and 9, because we add in our fifth interval will be 88, and 88 and 2 is 90. So it corresponds similarly that the total amount of vehicles is 90, so our cumulative frequency grand total is 90. Now, of course, as we continue using a scale, they're going to ask us to plot the cumulative frequency curve. Now, if we look at the scale there, 2 centimeters is to be given to represent 20 kilometers per hour on the x-axis, and the graph that I'm using, the darker boundaries represents 2 centimeters. You please measure yours and make sure it's also the same. Right? If it's 1 centimeter, well, you know, then 1 centimeter by ratio will give us 10 kilometers per hour. So mine is 2 centimeters, so I'll put 0, 20, 40 going up the road, up to 120, because look at our boundaries and all our data. The largest is 119, so we should go up to 120 at least on the x-axis. And similarly, as we label the x-axis, we label the y-axis cumulative frequency, and it must go up to at least 90. And follow the scale. 2 centimeters is 10 vehicles, so 0, 10, 20 up the road. Right, now that we know this, we need to get the upper boundaries, because that is what is required, those values, in order to plot a cumulative frequency curve. So for the first interval between 19 and 20, we already identified 19.5 is the upper interval, and then add 20 to that, 39.5, 59.5, and so on until we get all. And how do you get the first interval? Well, that will be minus 20, which will be minus 0.5, so we'll assume that to be 0. And at that point, where the speed is 0, how many vehicles do we have? 0. So we have our first point. We have all the x values, which are taken from the speed in kilometers per hour, written in blue, and all the cumulative frequency, the third column. So we can now plot our values, and we're able to plot 0, 0, 19.5 to 5, 39.5 to 16, and we continue until we get our last point, which is 119.5 to 90. Now that we're able to do that, we have just been able to plot 7 points. So we now take our time and draw a clean, smooth curve through all the points. We can use a flexible curve or a French curve if we're not able to do it freehand. Please make sure it's one smooth curve and it's not seen that it's parts that are joined together or a series of straight lines, because this is a cumulative frequency curve, not a frequency polygon. Right, now that we've done that, the next part of the question, part D, on your graph, draw lines to estimate 50% of the vehicles. So if we had 90 vehicles in all, right, then 50% of that is 45. So our line, I have it in red, will be a horizontal line going from the y-axis, moving to the right until it intersects with the curve. And where it intersects at that point, we draw a vertical line downwards, dotted lines, and we read off that value. And that will be our part 2. What is the estimated speed? So what they're really saying is, what is the median? May 2018, number 5A, students in a group were asked to name their favorite sport. Their responses are shown on the pie chart below. And if we look at it, we can see that there are 3 responses. Students chose either tennis, cricket, which is in light blue, or football in purple. And we're also giving that tennis is 45 degrees and cricket is 94 degrees, with the rest being football. So calculate the value of x. That's part 1. Well, the total of the angle in the center of the circle would be 360 degrees. So if we add all 3 parts, it should give us 360. So 94 plus 45 plus x is equal to 360. We can sum the 94 and 45. That will give us 139 plus x equal to 360. Notice we're trying to write vertically downwards such that it shows a nice flow in your working. X under x, equal under equal, 360 under 360. Right, so to carry us to our third line now, since 139 is adding on the left side, we can carry it across, which means the additive inverse, or we can say if it's adding on the left, it's subtracting on the right. So 360 minus 139 is equal to 221. As such, x is equal to 221 degrees. What percentage of the students chose cricket? Now, we know that cricket is 94 degrees out of the entire thing, which is 360. As such, we have it as a fraction and we need to convert it into a percentage by multiplying by 100. So cricket is equal to 94 over 360 multiplied by 100. You can use your calculators and that will give us 26.1%. And for the last part of the question here, for A part 3, given that 40 students chose tennis, calculate the total number of students in the group. So there are multiple ways to work this out. The method I will be using would be using ratio. So tennis, we know it's 45 degrees and that's equal to 40 students. So I can find for 1 degree. How do I find for 1? I divide by 45 on the left hand side. So I divide by 45 on the right hand side. So 1 degree will be 40 over 45. And as such, if I want to find for the total will be 360 degrees. So how do I go from 1 degree to 360? I multiply by 360 on the left. So I multiply by 360 on the right. So it will give me 40 over 45 times 360. 45 into 45, 1. 45 into 360, 8. Of course, you can use your calculators to work this out. 8 times 40 is equal to 320 students in total. May 2018, number 5B. The diagram below shows a frequency polygon of the number of goals scored by teams in a competition of 25 matches. We can look on the x-axis, we see the number of goals scored, and we see the least amount of goals scored in any game was 0, and 5 matches that happened. And the most amount of goals scored in any game was 6, and only in 1 match did that happen. So part 1, complete the following table using the information in the diagram. Notice that in the first row, it shows us the number of matches, F, which is our Y values, and number of goals scored, X, which will be our X values. We can see the third column missing. So for the number of goals scored, which were 2, how many matches did that occur in? And that was 3. And how many matches were 5 goals scored? And if we look at that, we could read it out from the graph, 2 matches. As such, we've completed the table there. But we'll take this opportunity to find the totals, that in the number of matches of 5, there were 0 goals scored. So in total, 5 zeros are 0. So we can find Fx. We're putting in a third row. And similarly, there were 7 matches with 1 goal scored in it. So the total number of goals scored in those 7 matches would be 7 ones are 7. And 3 twos are 6. So it means 6 goals were scored in 3 matches. 3 threes are 9. 4 fours are 16. So 16 goals were scored in 4 matches. There were 2 matches with 5 goals each, which gave a total of 2 fives are 10. And the last one would be 1 6 is 6. So we can find the total number of matches, and that was given in the first line as well, but we can total the the first row across, 5 plus 7 plus 3, going on, and that will give us 25. So sigma F is equal to 25, and that corresponds with the 25 matches given in the question. And the total number of goals scored in total, sigma Fx, would be 0 plus 7 plus 6 plus 9 plus 16, going on, and that will give us 54. So part 2 of the question, what is the modal number of goals scored by the team? Meaning, we're looking at an X value here. So which one of those was the most popular? Well, it was matches with only 1 goal scored in it. That would be our modal number. And that happened 7 times, the most times. Determine the median number of goals scored by the team. And there are multiple ways to do this, but finding the median normally means putting things in ascending order and then finding the middle. Since we have 25 items, then the exact middle number would be the 13th item. So if we list the number of goals scored in order, we will find that we have 0 occurring 5 times. So there were 5 games with 0 goals, and then 7 games with 1 goal. So 5 and 7 is 12, and the 13th game had 2 goals in it. As such, the median will be 2. Calculate the mean number of goals scored by the team. Let's recall the formula. Mean, represented by x bar, is equal to sigma fx, which is the total number of goals scored in all, divided by sigma f, the total number of matches, which would be 54 divided by 25, which is equal to 2.16. In our next video, we'll be continuing with doing past paper questions in statistics from the years May 2019 until the present.